Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. When you have certain data in front of you, there are a couple of things you can do to analyze that data. One thing that you could do is you could just look at the sample space, look at the sample that you're looking at from the infinite population of that data, and then just see how that data is behaving within that sample space. Um, so just uh, understanding the statistics of the data, the attributes of the data, what's the mean, what's median. And another thing that you could do from this sample space you could create like a prediction equation on how the data would behave in a sample space that you are not seeing, but you can create a prediction for that sample space from the present sample space that you have in front of you. Now, creating this prediction is done by a very popular mathematical technique called linear regression. And we have heard and seen about linear regression since high school. It is a fairly common technique. But what is the intuition behind linear regression and why is it called regression? So, this is what I want to talk about in this episode. And in my mind, linear regression is kind of like guessing the recipe of your data. And I want to give you an example here of a food dish. So, um, let's forget about linear regression for a moment. Let's say we are testing um, a dish called scrambled eggs, and we have scrambled eggs for breakfast, and we have never tested scrambled eggs before. So just by taking a couple of bites from that dish, you could probably guess that there are eggs, there is salt, there is cream, and there is butter. Um, However, not only guess this, you can also guess that there could the portion of eggs is much more than salt portion in the dish, and cream and butter are fairly of similar proportion. So you can, I mean, if you can guess this, you can actually guess, like, let's say this volume of this dish that I'm seeing is probably made out of two eggs, um, one tablespoon of cream, few milligrams of salt, and one small cube of butter. Now, if you want to predict or know more about scrambled eggs, just or know more about the recipe of the scrambled eggs, just by eating scrambled eggs once is not going to suffice. You need to eat that dish many, many times, made by many different people, to maybe perfect the recipe in your head. And that's and what we have done in this situation is we were looking at the final dish, and we have regressed from that final dish into its ingredients. So if you were starting from ingredients, what you would do is you will mix those ingredients in the right proportion, and you will progress towards making the dish. But in this situation, we are looking at the dish and we are regressing towards its ingredients. And once we do that, and once we know the recipe of that dish, then you don't need to look at the final dish. You can make the dish anytime you want by looking at the recipe and the proportions of those ingredients. And that's exactly what linear regression means. So you have data in front of you, which is like a final dish, and basically one of the feature of that data is a dependent feature or your dish, and the other features of that data are the independent variables or the ingredients of that feature, the dependent feature. And what you are trying to do is you're trying to find out the correlation between the dependent feature and independent features together. And you do that by not only mixing or summing up the independent feature, you sum them up with a particular weight for each independent feature, and you create an equation for that data. Now with that equation, you can predict how the data would behave in some other sample space. But obviously, by looking at one single sample space is not going to suffice. That's why you create these linear. You should, in ideal situation, create these linear regression equations in multiple sample spaces, so that you know that the weights, or these weights are also called regression coefficients, you know the interval or the possibilities of these weights in different sample space. So you can predict the population parameters, or the population behavior with more certainty. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.